Okay, again, the annoying part about this problem is that it's not in user-friendly form, so we got to use completing the square to get there. Okay, so again, I'm going to factor anything in front of x squared out. So this is going to give me 16 times x squared minus 4x, leave a little space. Do the same thing with the y, factor out the negative 9. So that's going to be negative 9 y squared. Be careful with the sign. That's going to be plus 8y, leave a little bit of space, equals anything that doesn't have an x or a y, bump it to the other side, 224. Okay, now back to algebra 1, completing the square. Take half of the middle squared, so that's negative 2 squared, which is 4. Half of the middle squared, so that's 4 squared, 16. And did I just add 4 and 16 to both sides? Remember, respect the distributive property. It's actually 16 times 4 that you added, so that's 64. And also negative 9, again, be careful of the sign, negative 9 times 16, which is minus 144, okay? So if I clean that up, this whole right-hand side equals 144, okay? All right, now I can begin the factoring process to get this to be a little bit more user-friendly. Okay, so it's gonna be 16, super duper easy factoring. That's gonna be x minus 2 quantity squared, minus 9, super duper easy factoring, y plus 4 squared equals 144. So again, the problem is this side needs to be a 1, which means I got to divide by 144, which means I got to divide everything by 144. And then it's just a matter of reducing these values, okay? So here's x minus 2 quantity squared. 16 over 144, if I reduce that, that leaves me with a 9 in the denominator, negative 9 and 144. If I reduce that, that's going to give me the 16. Again, this is negative, so this is my negative fraction, which means this is my positive fraction. Okay, and let's finish this up. So that equals 1. So because this is positive and this is negative, then I know it's got to be a left-right hyperbola. So just visualize this, okay? Once we have this user-friendly form, then it's just a matter of figuring out what the numbers are and just being able to do basic geometry translations. So the center, once again, really important, make sure you have 2 comma negative 4. A, the distance from the center to the vertices is given by this number right here. Be careful, I wrote this as 9. I should have written it as 3 squared, okay? Just to make it a little bit more user-friendly. So A equals 3, not 9. This is B, which is great, but I don't need B. I actually wanted C. So what's the relationship between A, B, and C? Pythagorean theorem. A squared plus B squared equals C squared. Okay, so C equals the square root of 25, which is 5. And then, of course, we'll finish up the asymptotes a little bit later. Okay, so again, the vertices based off of our center. Okay, the vertices are going to be left and right, which means I'm going to change the x, which means I keep the y value. So my y values should look exactly like this. In fact, since I know the foci are lined up as well, I could set it up exactly the same. Now all it is really just adding and subtracting the respective A and C distances, okay? So if I want to move to the right, I add 3. If I want to move to the left, I subtract 3 from the x coordinate, which gives me negative 1. Then for the foci, which are further out, I had to add and subtract 5, move 5 to the right and left. So 2 plus 5 to the right gives me 7, negative 4. That gives me this guy. If I move 5 spaces to the left, 2 minus 5, which gives me negative 3. That gives me the location of this one, okay? And then finally, for the asymptotes, should be pretty easy if you remember Algebra 1, point-slope form. So these are the numbers that I need. So it's going to be y plus 4 equals my slope, and then x minus 2, okay? So what is or are my slope? It's always going to be plus or minus because there's always one going up, one going down through the center, which is why that's the common point. And then it's just always y over x. So y over x. So it's going to be 4 over 3.